this. So tonight we have a presentation by Dr. Leonard Ginsberg. And Len, I've known for many years. We are colleagues, longtime colleagues at Western Michigan University, and Len, of course, is a long-term stalwart member of the Torch Club, twice president, and twice vice president before president. So we're looking for, of course, people to step into that esteemed position. By origin, Len is a fellow Pennsylvanian. I'm from Pittsburgh. Len and Linda are from Reading, Pennsylvania, in the central part of that beautiful state. Len is a graduate of Albright College in Reading, where he majored in biology, graduating in the late 60s, and then moved east to Philadelphia to Temple University, where he earned master's and doctoral degrees in biology. Leonard came to Kalamazoo in 1977 to join the biological sciences faculty at Western Michigan University. There he made major contributions to WMU's development into a recognized national research university. That meant Len established quite a reputation as, what shall we say, a grantsman. So Len was awarded major federal funds for his research in molecular biology and in vitro toxicology. He obtained major grants from the NIH, the National Institutes of Health, and from the National Science Foundation to assist students in their studies and developing career opportunities in the sciences. With talents like that, Len was inevitably drawn into administration. He served as chair of the Department of Biological Sciences, rose to Associate Dean of the College of Arts and Sciences, up to Associate Vice President for Research, and Interim Vice President for Research. So he established in Western as a contender in the game of federal grants recognition. He established the Environmental Research Center and served on the development team for Haneke Hall, the university's major science research building. Len's distinguished career as teacher, researcher, and academic administrator spanned 35 years. In 2013, he formally retired, but he has stayed connected as community professor with WMU's Stryker School of Medicine. Len and his wife Linda are world travelers and, I understand, ardent foodies, as well as wine connoisseurs. I remember running into them occasionally at Costco in Grand Rapids, where they like to shop for wine, me too, and think that the selections are different than Kalamazoo, maybe better. They love to travel with old friends and visit vineyards. I still remember hearing stories of their visits to Argentina and Chile. They liked to travel, and then came COVID. Confined, like the rest of us, to Kalamazoo by pandemic restrictions, Len and Linda found a way to cope. Still a scientist at heart, he hit upon a project that would incorporate his experience and skills in genetics, research, and food. So tonight we have a very interesting scientific presentation about dwarfs, microdwarfs, and other mutations that developed during the past challenging 2 years. So welcome, please welcome Dr. Leonard Ginsberg.
Thank you, Howard. Can you hear me? Yes, okay, good. Yeah, Jim Coppinger made this sound more exciting than it is, so I hope you're not disappointed. But this is a pandemic project. What an old genetics professor does when he has nothing else to do, all right? So So where to begin? So in January of 2020, we had stayed the month in Tucson, and we had to drive home from Tucson. And as we drove home, it's a long way. You get to think about what's going on. And all I heard on the radio was China is being overrun by some mysterious disease. Our president saying, don't worry, I'll block them at the Mexican border. And the next news would be that there's some plague going on, some E. coli, something else in the vegetables we're going to eat. At the time, everything was contaminated with something. So I thought, well, it might be time that we're going to have to sequester. I didn't think it would be for 2 years, but I thought we'd have to stay home for some considerable period of time. And while we're doing that, I might as well grow some things we could eat. So this became the project. The project essentially boiled down to creating a home greenhouse, indoor greenhouse, with the modern techniques that are available now. And so I'm going to tell you about this journey, and you'll see how the genetics fits in with that. So anyway, this was a perfect project for a retired genetics professor. It involved playing with equipment, making up chemical solutions, which I always enjoy doing in the lab. And it involves some computer searches and growing alternate forms of life in a mason jar. So, you know, that's what could be better. The only thing could be better is if you could eat the results of your experiment, which you can in this case. So this was really great. And there was no grants to write. There was no papers to write. And this is the only lecture. So it was a win-win situation. So, so what I'm going to talk about is sort of the journey through this, this process. So, did I move it? Yeah. So Linda and I have always been interested in outdoor gardening. We have a couple raised beds. We have a relatively small area, as you'll see. But we have a couple raised beds, and every year we would plant some tomatoes and so forth. And we'd always look through the catalog and find, you know, that amazing tomato that we were going to try to grow. So I would pick one tomato out of the catalog. You know, it could be something interesting from Italy, you know, or just something that was supposed to pop a tomato out by the 4th of July. It never really worked very well. But every year we would start that, and then we both like very tall flowers in the front yard. So we would always grow, you know, 30-inch tall marigolds and zinnias. So those we had to start from seed. Everything else we would sort of find. But over the last few years, although we have an amazing bedding industry in Kalamazoo, it was getting more and more difficult to find interesting varieties. Everything seemed to be chef somebody. I don't know who the chef is, but if you go to the various greenhouses, you'll just find this chef guy who figures out which ones you need. Anyway, so in this, and many times we have gotten our vegetables mixed up. We go in, we think we bought a sweet pepper, and the next thing, when it finally grows up, it turns out to be a jalapeno. People keep moving the stickers around and the parts around. So we needed somewhere to grow things from seed better, and this was at the time, this is what we had. An old utility light, shop light. I built this beautiful holder out of PVC pipe, and it was a fluorescent light. You had to have it about that far from the plants for it to survive. And so on the way back from Arizona, I thought, you know, we have to improve this system. We have to see if we can come up with something better. And Kalamazoo is a good place to do this work. There's a lot of marijuana growers, so there's a lot of places you can get the supplies, but you could also go to Amazon and other places to do that. So the other part of this was I wanted to go into hydroponics rather than soil. So we see this is, so all this is available. And what we're going to do, we're going to see that this isn't too much different from an aero garden. Everybody ever see these aero gardens? They're little things that you can hydroponically grow, but they're about that big, and they have a little tiny light at the top, and they cost about $200. And so that, if we just wanted to grow lettuce, we could have found one of those, but this system allows us to also start seeds for the outdoor garden. So we needed something bigger, something we could do something with. So right now, it's relatively cheap to start this system. The advances have been tremendous. Their LED lights have really revolutionized the growing indoors. You can find LED lights used to be $20 last year, but now there's a little bit of inflation going on. But you can find wonderful LED lights that you can just put above some plants and they'll grow perfectly well. You don't have to spend a lot of money on that. You can, the fertilizers, again, are because of the marijuana growers, you can find these everywhere. The special fertilizers for hydroponics, all the special cups and stuff that you need are all available in town and on Amazon, so it's really easy. I have to get my props. Okay, so I'll talk about this in a little while. But this is what you grow, hydroponically, what you grow. You buy these little, what they call net cups, and they're just, people make these out of plastic. They just cut slits in it, but this is a real one. It doesn't cost very much. And the growing media is a sponge. It's a sponge made out of primarily coir, cocoa coir, and some probably plastic. Who knows what's in it. But the interesting part is, as you're going to see, you simply put one of these into the cup, you suspend this in some water or some fluid, and amazingly, the roots come out the bottom, and you will have a hydroponic plant. So I'll show you how this works in a few minutes. So it's very easy to actually get going. And let's see. I think I missed the slide here. You can tell I haven't done this in a while. Right. So this is an example of what we did. This is a 2.5 gallon container. I poked some holes in it, 2-inch holes, insert the cups in, and magically put the hydroponic fluid underneath, and magically you get a big container full of vegetables. So it's pretty amazing to watch. So hydroponic farming is really becoming very popular. I thought I'd just add this slide. It's at least a $10 billion industry right now, and it's supposed to double in the next couple of years. And even Bill Gates is investing in hydroponic gardening. It's reportedly, these are the points that people, when they went for funding, this is what they say. Most of it's not true, but this is what they say. The when I looked up the statistics, it said growing hydroponically is 3 to 5 times faster. That's not really true. For a small portion of the life cycle of the plant, that might be true. It's probably closer to the figure I saw recently of 30 to 50% faster. It is faster, but it's not 3 times faster. And it may well, since 3 and 5 and 3 and 5, it may be somebody who didn't know percentage actually just took 3 and 5 and made it 3 times. So I'm not quite sure. Commercially, it's 90% less water, so a lot of places in the country don't have enough free water. And here it's amazing. You can recycle the water. You can use it in small containers. and you don't just flood areas with water. Very, very specific. The crop can be grown year-round, which is great, and relatively short half-life. You can make a lot of vegetables in an urban area. You just take an old warehouse, convert it to hydroponics, and you don't have to truck the material hundreds of miles. You just take it down to the next corner and deliver it to some grocery store. So it's pretty amazing. What I liked about it was the quick turnaround. When I was evaluating various seeds, you could, within 30 days, you could pretty much tell whether this was going to work or not. I remember one of my colleagues was a corn geneticist, and he would do an experiment, and then he'd have to wait till the next corn season to do the next experiment. And so that took a long time for him to get his PhD. And it eliminates soil, and but not many of these things aren't available for our home use. So you don't want to have a giant vat of fertilizer in your living room, right? So, and you don't want to have a lot of pumps and fluid running through the system. So it turns out that there's a much easier way. And in the University of Hawaii, Dr. Kratky discovered that you didn't need all this pumping and all that stuff, that the plants knew what they were doing, and if you just gave them the hydroponic solution, they would grow perfectly well. So here's one of the plants that I was working on. So again, I could pass this around. You plant the seeds on the top, which I'll show you, and what you can see here, this is a Swiss chard plant, and it's a yellow Swiss chard. So interestingly enough, the roots grew yellow. So this is when you first start this system, the Kratky method, you put the solution up to about here, about a quarter to a third of the way up the net cup. And then as the plant grows and develops, the water starts to fall. Some of this is because it needs water for the photosynthesis, but other parts of this is just, it starts to draw the water up by transpiration. Anyway, and so the water begins to fall further and further down. It will actually suck the container dry. Then you could fill it again, but there are actually two kinds of roots here. One kind of root is up here, and these are the air roots, and they're used for the plant for breathing purposes. So if you fill it up again, you can't fill it up higher than about here. If you fill it up to about here now, you'll kill the plant. So this is just a very simple method. It doesn't require any pumps or anything. You put your seeds on, and so this is the way I was growing things. And here's our first, here's our system that when we came home from Arizona. We went down almost the next day to Costco, and I bought a new rack. This is it's kind of a baker's rack, 6 foot tall. I bought a couple LED utility lights, and I bought a couple lights from Amazon. We went down and we got the sponges and everything from Amazon, and then I went to Menards and started looking for seeds. And so I picked out a cucumber, a tomato, and a bunch of lettuce seeds and brought them home. And then the pandemic hit. So by February 15th, this whole thing was set up, and we were starting to grow some lettuce indoors, mostly leaf lettuce at that particular point. And so here's what the fertilizers look like. They're actually very special. They're usually in 3 parts. And so this one's a liquid one. And the instructions are you take a teaspoon of one and put it into a gallon of water. You put a teaspoon of another, and you put a teaspoon and a half of the other one in. And shake it up, and that's your solution. And then depending on what kind of water you use, you have to sometimes pH it to pH 6. So it takes about 5 minutes and you have a gallon of the solution. That's relatively simple. But this is the more very common one. This is a solid one. It's a lot cheaper to work with, about half the price or less. And you buy this one for about 14 bucks. Then you go down to Walmart, you go down to Walgreens and you pick up some Epsom salts. And you go to Menards and you pick up the calcium nitrate. And it costs, this is about a 10-year supply. So, because there, in this case, you use like a half of a teaspoon of each one. So okay, so you can see over here, I was growing them initially in mason jars, and they're covered with aluminum foil. That's not because of radiation. That's because if you don't block the light, you'll get algae growing in the solution. Okay. The critical part is to have some light, so you can use utility lights, shop lights. You can use strip lights. These are panels. They're not too expensive, and they will light up a huge area for relatively. They require about the wattage of a 100-watt bulb. That's about what they do. You don't buy one of these. These are the ones on Amazon. You'll see them everywhere. They're usually purple because that looks good. And they have so little light that they're useless. So this is the critical part of the whole process. All right, well, let's get into the more of the thing. So here's the actual seeding. You neck cup, we put some seeds on top of the thing if they're small seeds. And Linda has figured this out. She does most of the seeding because I'm not good at tedious tasks. So Linda will do most of it. But she's figured out how you could actually get one of those blended seed things where you get a lettuce mixture in one package. She can actually seed one of these with the mixture, and one sponge will have the whole mixture of lettuce and stuff. In the center of the sponge, there's a bigger hole. So if it's something that's a little bit bigger, like a tomato seed, you just stick it in. You don't cover it with anything. You don't put any soil on top, nothing. You just stick it into some tap water and wait till a root shows up at the bottom. So once it gets its true leaves coming out, then you can transfer it to the hydroponic solution. Okay? And so in the first couple months, we had good luck. I grew a lot of lettuce, leaf lettuce, relatively easy. It takes from seed less than 30 days to get a crop. And it's amazing how fast the actual getting the seed to start takes a couple days. The sponges help that. And to get the root takes a few more days. And then once you put it in the hydroponic solution, it seems like you turn around one day and you have these little tiny things, and you come back a couple days later and it's time to eat lettuce. So this is where the 3 to 5 times faster really makes some sense. It really goes very, very quickly once you get to that stage. So we grew some lettuce. I tried cucumbers, and this was a cucumber we got, but it's too difficult to fertilize the cucumber, and I couldn't get it enough of them fertilized. And so clearly, the variety that you pick is important. It's not just having the lights and the solutions and stuff. You have to find the right variety. So the same thing with patio. I found a tomato, but it was a patio tomato. It was too big for the system. That didn't work either. So I went down to the store and to try some different seeds, but by March, everybody was out of seeds. So there wasn't even enough seeds to start our garden outside. I had to go down to Myers and get a sweet pepper get the seeds out of it and start to pepper from the seeds from there and things like that. We did have a collection of lettuce seeds and stuff that we used, but it was very difficult to get seeds. And all the major companies, the seed companies, were out of seeds or had a message on there that said, we are supplying the seeds to the farmers. If we have anything left, we'll let you know. So this was an interesting time. So we planted our outdoor garden, and then I started searching online to see what seeds I could get, what different varieties we could get. So this is sort of the research part, trying to see what was out there, what we could do. And so I was looking for something that was rather miniature, something that only grew a foot or so tall at most, and something that would grow rather quickly, various criteria like that, trying to see what we could see. Because you can't eat leaf lettuce forever, you know. So we needed to do something. So we wound up actually growing a variety of things, including bok choy, kale, cucumbers, peppers, tomatoes, all hydroponically in our system, and Swiss chard, dwarf kale of various kinds, and those are the major ones that we sort of grew, and I'll show you some pictures of some of these coming up. So it was pretty amazing what you could actually do with this system without any pumps or anything of that nature. So here's some pretty pictures of what some of these look like. For example, we're growing a cucumber plant, and actually you didn't want to put the cucumber plant under the light. I found out that it was best to have it back from the lights, and then the vine would crawl into the rack, and it would find its way everywhere. And we were getting 6 or 8 cucumbers a day out of the cucumber, out of one plant. In fact, Linda would say, no, no more. And on one stem I saw the other day, it had 29 potential cucumbers on it. So the other thing we grew was the Swiss chard. I found a particular strain of Swiss chard that was really good. I tried a couple different strains. They really didn't do much. And then I found this particular strain, and it just took off. So it's quite amazing. And here's, this is an heirloom Scottish dwarf kale. And there's also a Russian dwarf kale. And they both grew extremely well. And amazingly, the flavor was different. It was much sweeter. Wasn't nearly as leathery as sometimes kale can get. And it's a much different taste than you would get. We then started looking at things like herbs, what herbs we could grow, and I found seeds of all kinds of interesting herbs, which I'll show you in a minute, but herbs that we normally wouldn't have gotten had we gone to one of the stores in town. This one is a sage that has many times more sage oil than the normal sage, and has a very, very unique heavy sage flavor. So and this is just some plants that we're growing for outside bedding. So you can put them on the floor, you can put them under the lights, they all work. And this is what the system looks like today. We have an area for herbs. This is for various plants that we're growing, lettuce and other kinds of crops. And then another one over here, we split the rack in two, and this is where we start much of the seeds, and then there's where the cucumbers would go and so forth down there. So. Oh, I want to show you this one. This is a micro dwarf tomato plant. So after searching all over the web to find short tomato plants, I kept reading about these micro dwarfs. I thought, well, that's a nice name, you know. So I traced down the couple seed companies that were selling these micro dwarfs. They only grow 1 foot tall, and they are packed with cherry tomatoes. And I brought along some that we grew from seeds, so if anybody wants to try one, we have some that you can take with you to try. You have to put these into a 1-gallon pot, or you can put them in a bigger pot and put some flowers around it, but they're only going to grow about that wide, and they're going to grow about that tall. And then they produce their tomatoes, and once the tomatoes are all done, the plant dies. So it's a determinate plant. But they're really amazing, the yellow ones and all kinds of different flavors. So here's some of the varieties that I was able to locate that worked really well. This was, first one is the cucumber, our favorite. It's called Katrina. It's only 6 inches long. It's sort of like those little greenhouse cucumbers that you could see in the market. And this is the one that grew tremendously because you don't have to fertilize it. It's self-fertilizing. It only produces female flowers. And so whatever flower comes up, it will fertilize and you'll get a cucumber. And so it's really an amazing thing. It does not grow well outside at all. We tried to grow it outside. It doesn't grow. But we have another one that's a longer English cucumber that's also self-fertilizing. It does grow outside. But anyway, this one's a really amazing one. This is the sage that I was talking about, very high oil content. When I started looking through all the seed catalogs and trying to locate, there are countless varieties of basil that are available that we normally don't see. And some of them are very tasty, much different than Genovese. They have slightly different flavors. And we made a pesto a week or so ago. We just pulled some off of each plant. And we're growing 4 pots, and it really was good, really good. We grew za'atar, which is a Middle Eastern marjoram. We love the Asian greens, bok choys and toi choys, which I'll show you a picture of. They grow very, very quickly within about 30 days, 25, 30 days, and they're just really good. The lettuce, we started growing head lettuce, little Caesar romaines. They're about that big, and they're romaine lettuce that grows really well in the hydroponic. And habanero peppers. These are habanero, a mutant of habanero, which has no heat, but has the flavor of a habanero pepper, but is completely without heat. And they grow a beautiful plant outside, beautiful plant, and we use them in everything. So, and so then I found a tomato that's really interesting. It's a dwarf cherry. Some people use Tom Thumb. This is the dwarf cherry. We found you can get the seeds at Wedel's. But the dwarf cherry, it grows up about 6 inches, the main stem, and then starts branching like crazy, and then overlays the bucket you have it in, and that's why it's called falls, just overlays it. It grows a crop of wonderful cherry tomatoes and then dies. And so it's really, really interesting to work with. Then I talked about microdwarfs. These are a whole variety of very tiny little tomatoes. And I brought some with us. And if you want to try some, you can take one home and give it a shot. And they're less than a foot tall, and they have many varieties, red, yellow, all kinds of things that you can do. All right, so here are some of the plants that I was talking about. This is cherry falls up at the top. It's a very ugly plant. It just grows up and then sort of sprouts everywhere, but they grow the very good sized cherry tomatoes. This is toi choy. It's only that big, but it grows very quickly, and it's very good to eat. There's our Katrina cucumber, and you can see these are all cucumbers waiting to get bigger. Who would have thought you could do this with just a couple solutions and a sponge? You know, quite amazing. Quite amazing what you can do. And this is just for fun. I grew a poblano pepper, which is you know, about that big, tall. But instead of putting it under the lights, I put it aside of the rack. And it's not so much how much light they get, but for how long. So we have a light cycle of about 16 hours. So if they're exposed to a reasonable amount of light for 16 hours, you can get a lot of things to grow that aren't. The nice thing is you don't have to use any pesticides. You don't have to, hopefully, very few bugs. And the only bugs that we ever had was that you can get gnats, what do they call them? Moths, mold gnats or something like that, which happens if you water the plant from above. If you water from below, you don't get it because it's in this peat moss. They're in the peat moss. Okay, so again, here's our basil collection up the top. This is some more bok choy. This is a ramen we made. And here's the cucumbers, the various micro dwarf tomatoes. This is how big they get. Parsley, and here's our collection of herbs. So this was a real fun project. Kept me interested through most of the pandemic, and we still are continuing on eating this stuff. As I was going through all these catalogs and reading about all kinds of things on the web, I kept coming across something called the Dwarf Tomato Project. And that sounded interesting, but I couldn't quite find the original reference. But eventually I found something called the Dwarf Tomato Project. And it was started by an individual, Craig Leflier, something like that, and from North Carolina. Apparently, his career was in the pharmaceutical industry in North Carolina, and then when he retired, he decided to do gardening. So he had a huge collection of heirloom seeds, which I assume he was growing some of them up. He would take them to the farmer's market, and people said, oh yeah, they're really lovely, but what I really want is something I could grow in a small pot. Because the heirlooms often are 8 foot tall. And a lot of people's yards, that would be too tall. So he got on a gardening website with an individual from Australia, and they had the discussion about this. What could they do with all these heirloom tomatoes, but make them smaller? And he said that there were a couple of heirlooms that were dwarf, that were small. And so she said, well, I'd be glad to do the breeding, the F1 hybrids and so forth, but it's really quite a bit of a task to then get the purebred tomato that you want out of it. So they went on the website and they got hundreds of volunteers who were willing to grow out the hybrids they produced. So if you imagine when you do an F1 hybrid that you often find in the seed companies, the seeds are all the same. But if you were to grow them out, grow those seeds out, you would get a whole mix of things. The characteristics would be kind of random unless you grew out all of them. So it would be like taking Indian corn and trying to, without the color, and trying to figure out which seeds was going to be the one that was worth propagating the next season, right? So what they had to do was essentially do the crosses, then do the next cross, and then select for a tomato that tasted good, that was dwarf in size, and had various characteristics like that. And they came out, today there are 120 different strains of dwarf tomatoes that grow about 4 foot tall and produce normal-sized heirloom tomatoes. And they are unbelievably good. And so last year we grew 7 different varieties. I have many more seeds than that, but we grew 7 different varieties, and we're going to grow another 7 or 8 this year. And so we're growing them in is felt bags. This is better than using raised bed gardens. I know you started a raised bed, but these are 7 to 10 gallon bags. There's actually make smaller ones. You fill these with the dirt, and you can put a tomato in a dwarf tomato in a 7-pound, or a regular tomato in a 10-pound bag, 10-gallon bag, and they work amazingly. The roots, instead of forming a circle around, they stop right at the edge of the bag. So they grow much better root systems, and they're easier to maintain, and they drain very easily. So you can find these everywhere. This is a part of our garden last year. This is the driveway here, and so part of the crop we grew right on the driveway, and the other part is in the raised bed. But this is, and they grew unbelievably. We kept the deer away for some reason. So this is what these tomatoes look like, these dwarf tomatoes. These are Tasmanian chocolate, scarlet, sweet scarlet, beautiful tomatoes. In fact, they're so pretty that Linda wound up doing drawings of all of them as we picked them. And they were very prolific. The plants grew, it's about 4 foot tall or so. And some of them continued to grow throughout the whole season. Some of them did a crop and then quit. But here's what the insides look like. You couldn't ask for a better tasting or prettier looking tomatoes. So these are very interesting. Part of the deal when you signed up for the tomato project was that you couldn't patent the seeds. So when they selected them, people would say, oh, I'm going to select this yellow one. And then they would continue to breed it. You could name the tomato that you selected for, the family could. Usually it's named after your dog or something, you know, or your aunt or somebody. And so there's all these interesting names. But you can name it, you can't patent it, you can sell the seeds. But you don't often find this in commercial seed companies. You find these in a couple places, tomatofest.com, for example. So, so this is my story. It was a fun journey to go from one part to the next of this, and looking through this. And here's a nice selection of lettuce. We are very fortunate. We have some really good marijuana-related grower in town, stores. And when I first wanted to see what they had, I was a little afraid. I didn't know what I would find when I walked through the door, what it would be like. But it turned out they were very nice people. They have a huge selection of things like the neck cups and cocoa coir and all kinds of things. Apparently marijuana people love cocoa coir. I don't know why, but they have huge amounts of it. And they grow, they have all the nutrient solutions, cheaper than you can get on Amazon. And so there are 2 of them. One's actually near Drake in West Main, and the other one is at the foot of Westnedge Hill. It's a real interesting plot. So, well, I think I'll stop at that point. I'd be glad to take questions. I'll start up here.
Early on you mentioned water roots and air roots, and are air roots something that exists in nature?
The type of water? Or?
Well, the air roots.
Yeah, the air roots are above the normal roots, and you can't fill the water up and drown the air roots. You can fill the water only up to the level of the yellow roots, essentially.
Len, real interesting talk. It's given me lots of things to think about. But you mentioned something about the light. Now, I kind of always had this idea in the back of my mind that you had to have specific wavelengths in order to grow things successfully indoors. But you suggest
It
that
doesn't really seem to be that way. I mean, you know, you'll see there's a big debate going on, well, whether the light should be blue or red or white. And it might make a difference for marijuana, but it doesn't make a difference, doesn't make any difference for lettuce. And if you did the red ones, your house looks really weird by having these red lights going on. So they love the LED utility lights, which I got at Costco, and I can grow the whole lettuce crop just under those utility lights. If I were to start, I'd just go down and pick a $20 utility light from Leonard.
An upswing in your utility bill after all of this, was it
No,
expensive?
we haven't really seen it. We're
No,
talking.
Not really? That's interesting.
No, it's like a 100-watt light bulb that's on, you know, and we don't grow the whole season. When we went to Tucson, we stopped in December, nothing for a month. And during the summer, we'll plant everything in the garden, and won't be till sometime in September we start again.
When will these vegetables be served at Torch?
For all we know, they may be served now, because more and more of our vegetables, their lettuce in particular, is going to come from this. You can't grow carrots, you can't grow, you know, wheat, you can't grow some things. So some things clearly have to come from farms. And but lettuce, it doesn't make any sense to plant a big crop of lettuce on a field. If you can grow it in layers in a warehouse.
Are you finding about this in your studies, or were you at all interested in the nutritional value of the products that you were producing?
Well, if you read the hype, there's more nutritional value in the hydroponic plants than there is in the ones grown in the field. They get all the nutrients they could ever want, and we've actually also tried the microgreens, which are supposed to be much more nutritious. They grow about that tall, all kinds of things. But to be honest with you, when we tried the microgreens, you can get microgreens in 15 days, and they're about that big. But if you wait another week or two, you can get a whole plant. So it doesn't. So we're using the microgreen seeds to get plants ready for something else. So nutritionally, you know, I think they're at least as good. And for example, as I said, all the herbs actually taste much better. A lot of the vegetables takes a lot cleaner. You can mess it up. In the beginning, when I was experimenting, you can make up these solutions of various strengths. So I was using aggressive growth strength, and it was shooting up. But after shooting up for a while, it would start to go bitter. The lettuce would start to go bitter, just as same thing happens when you expose your lettuce to too much sun, and it's growing too fast. So back off a little bit, and everybody's happy.
I'm curious about the cucumbers. You say they produce flowers, but they self-fertilize. It sounds like you're sort of putting the bees out of business here.
Yeah, so they produce female flowers. They fertilize themselves somehow, and that's it. And there's no male flowers involved. This is the women's rights movement of cucumbers. No male flowers at all. No male flowers. Oh yes. Well, one thing, this has nothing to do with cucumbers, but if you're going to grow peppers or tomatoes, you have to pollinate them yourself. And this is my SpongeBob toothbrush, electric toothbrush, and you just touch this to the little stem where the flowers are, and it magically fertilizes. You can see the pollen coming out, and it magically fertilizes the tomatoes. And I use this outside as well. It does an amazing job. You get a very high percentage. Turn on the power, touch the back to the top of there's a vibration. They think it's a bee. And it fertilizes the thing, and you get an amazing yield of tomatoes. So all the outside tomatoes were also done this way. But you can't.
Len, could you briefly say something about hydroponics as a way of solving world, starvation issues?
So that's what Bill Gates is investing in. There's quite a bit of controversy as to whether you should use artificial lights or not. And Bill Gates is spending $1 billion or whatever. They're making big greenhouses in the middle of the desert so they don't have to use artificial lights, but they're using all hydroponic solutions inside, and it's all robotic. So we can actually, have a robotic thing say, oh, do you need more water? And they give it a little water. Or do you need this or you need that? And then there's the other things that you can grow tremendous amounts of lettuce in a small building, because the lights go all the way to the ceiling, and there's a conveyor belt that brings the things back down. You harvest them, and goes back up with new plant in them. The other one I saw was a giant swimming pool. And they put the net cups on a piece of styrofoam and push it out into the pool. And then by the time it makes it to the other end of the pool, it's lettuce, and they harvest it. And they start on the other side. So,
Hi, Lynn, excuse me. How do this plant get their nitrogen? Because nitrogen comes from bacteria, the root, right? The symbiotic action. If we do it like this indoor and use all these chemicals, where those bacteria which are in the soil, they come in this system to provide the nitrogen.
well, then you provide the nitrogen.
So you don't need-
The
you don't need
mixture
that.
has nitrogen. Nitrogen actually is made from byproducts of natural gas nowadays. So they take natural gas and they process it, and it becomes nitrogen, mix it with a little calcium, and then that is part of the 3-part mixture that you need to get the plants to grow.
So you don't need the bacteria?
You don't need the bacteria to make it. But I actually grew beans, and I was really surprised that I actually got string beans. It wasn't worth the effort. We didn't get really enough to do very much with the meal, but I would have guessed that beans would have needed some kind of bacterial system to actually make the nitrogen, but they used the stuff without it.
Out of curiosity, is there any role for natural light at all? Is there any benefit to even, in the winter solstice, is there any benefit to exposing plants to natural light vis-a-vis artificial light?
You can do the whole hydroponic thing outside. A lot of people do that. They just take a 5-gallon bucket, put a hole in the top, put the net cup in there, and just have it exposed to the natural sunlight. And you will be able to grow your tomatoes or your lettuce or peppers or whatever you want.
The ones the deer don't eat.
Yeah, well, there's drawbacks to being
Yes,
outside.
yeah.
There's drawbacks to
But
being outside.
yes, okay. It
And
is-
other people just do the buckets on their balcony. They have a balcony and they have a couple buckets of this stuff, and they, grow tomato plants usually, grow tomato plants out there, and
But even in winter, is there any benefit to, that's kind of curious, is there any benefit in exposing your hydroponic plants to natural light at all? None.
no, in fact, one of the problems I have, we have one of the racks against the window and have to be very careful because the sunlight can come in through the sliding glass door and actually overheat the plants. So it's better having artificial light and knowing the distance and how much heat's coming out and so forth. Well, so we were in Tucson in this January. We got back a couple days into February. We seeded stuff. By the end of the month, beginning of March, we had lettuce and bok choy and all that kind of stuff. The cucumbers take longer. So what hydroponics speeds up is that kind of middle growth phase. Allows things to grow very rapidly. But for example, tomatoes, if it takes 50 days to get a tomato, it's still going to take you that much time at the end to get the tomato ripe. It doesn't affect the ripeness. It affects, getting to the right stage.
Aren't you tempted to write 2 articles, one scientific for a scholarly journal and the other one for a general distribution magazine like The Atlantic or Reader's Digest?
Well, I don't know if I know any more than a lot of people do. So, but, my days of writing scientific papers, do I get promoted again? Or, so, but I thought this might be an interesting talk for Torch. And as we went through the project, we started to take pictures and make notes of various things. And Linda was drawing things. I like to thank Linda again for doing a lot of work on this project. And so it was just fun to do, but it was nice to catalog it so that I could present it tonight.
We got one more.
That's okay. I just wondered, is the solution organic, or where does that come from?
Well, this is, as a biochemist, I would say stay away from organic solutions. And that's the general rule. There are people who want to grow their marijuana in organic, but what the organic stuff is, they isolate it from compost. Some manufacturer does in a very long and elaborate process, getting the nutrients out. Whereas that master blend solution, they just put in a little this, a little that. It's a few bucks, and the plants are very, very happy. They don't really care if it's organic, and neither should you. The plants will be organic. It will go into the plants, and the organic part will be the plant. So as long as they have pure chemicals, I'd rather have the pure chemicals than a mixture of garbage from compost.
One last thing I want to talk about is the work for the radio station, and some of these local companies wanted to advertise with us, but marijuana is still a federally illegal drug, so we're not allowed to advertise these programs. But yeah, you got too close to the speaker there. Sorry. We were talking, we were like, well, how do we advertise for these companies? Because everybody, wants to know about these things. We're like, well, everybody grows tomatoes, so that's our plan now. Is for these companies, it's not marijuana anymore. It's all hydroponics because everybody loves tomatoes.